So this is now the conversion from infinite term into finite term. From infinite term into finite term. So what should be the method? How do we proceed? How do you proceed?
Expand. Expand.
X?
Expand.
This total. And then,
Till few terms and then get pattern.
oh, so that is by trial and error. Is you may get the answer but not sure about it. So, what we should do is, we should write a formula for yn minus 1. Yn minus 1. So, what yn minus 1 would be? Summation. What is yn minus 1? Summation k equal to 0 to infinity a raised to k minus 1 x of n minus 1. Is it right? So, I use this. I will write it here. We write y of n minus 1 is equal to summation equal to 0 to infinity a raised to k minus 1 x of n minus 1 minus n minus 1 minus. Now, what is to be done is this you try to express, logic is this term you try to express sometimes this term. This term you try to express sometimes this term. What logic will follow? So you can change variable k by m. K minus, but this should be x of this one should come here. N minus 1 minus k, that should not remain. So that should become n minus m. So what you can have? What logic you can adopt? 1 plus k. So this I can put in bracket, right? Okay. So m equal to k plus 1. So k is equal to m minus 1. K is equal to m minus 1. So when k is 0, m is 1. Is it right? So what that will look as, k is m minus 1. So k, what is k minus 1? K is m minus 1. So this would be k is 0. So m is from 1 to infinity. From 1 to infinity, right? A raised to m minus 2, right? X of n minus. So it is just like, suppose if you are preparing some atom, maybe some recipe, you want some, the given thing is having something wrong, so you want to correct that. So you correct that, but that time what happens? The other parameter gets disturbed. So here we corrected this, we want it to look like this. So this got disturbed. kind of jugglery later. But the problem, what is the problem has occurred now? This m minus 2 has occurred. So that I don't do. That I don't do. So what can I do? That is m minus 2 is m minus 1 minus 1. And a raised to something plus something is a raised to something into a raised to some other thing. So this becomes summation m equal to 1 to infinity a raised to m minus 1 into a raised to minus 1, or m minus 1 minus 1, right? And this minus 1 I can write as is it right? Okay. So this term does not include m. If a term doesn't include m, that can be brought outside summation, or if some other term is taken inside also. So what I get is that is equal to y is equal to, not y n minus 1 is equal to a or 1 upon a, right? 1 upon a summation m equal to 1 to infinity a raised to m minus 1 x of n minus m. And what is our y? Y is equal to summation k equal to 0 to infinity a raised to k minus 1 x of n minus t. So now there is no point, we can use, once the idea is clear, there is no problem in putting k also. Is it right? So once everything is solved, there is no problem, because that when the summation is over, it becomes single term. So it is 0 to this and it is 1 to this. So what will you do? So this I can multiply by a on this side, this term. But here it is from 0 to. So what will you do? This term, this is infinite summation. You will separate out term for k equal to 0 and remaining from k equal to 1 onwards. So for k equal to 0, what is the scenario? For k equal to 0, it is, for k equal to 0, it is 1 by a, k equal to 0, 1 by a raised to minus 1, that is 1 by a xn, plus k equal to 1 to infinity, x, 1 to infinity, a raised to k minus 1, x of n minus. What is this? This is y. But what is this? What is this? This is a y minus 1, right? So yn is equal to 1 upon a xn plus a y of n minus 1. Is it right? Elements?